right, so in this video, we're going to be building on the concept from the previous video where we established a GRE tunnel. And so in this case, we're going to do something cool, which is to add another layer of encapsulation. So this will be GRE over IPSec VPN. And so essentially all we'll be doing in this video is we'll be configuring a site-to-site IPv1 tunnel between R1 and R3. And essentially what's going to happen is we'll send traffic from one of the LAN subnets that'll be associated with the GRE tunnel interface. So that first layer of encapsulation will happen with GRE, but then that GRE tunnel interface has a source of the gigabit 00, which we'll be putting a crypto map, we'll be associating a crypto map with, and then that GRE encapsulated traffic will then become interesting traffic for the IPSec tunnel. And so basically what will happen is we'll be sending GRE traffic through the IPSec tunnel. So that's generally the idea. So I'm going to start on router 1 here. And if you're familiar with VPN tunnels, or you watched any of my previous videos, then this won't be anything too new, but we've got to do some IPv1 phase 1 policies here. So we'll go crypto ISACamp policy 1. We'll do encryption AES 256. Hash will be SHA-1. Diffie-Hellman group 14. And the authentication is going to be pre-shared key. So now we got a phase 1 policy. Let's work on a phase 2 transform set. So crypto IPSec crypto IPSec transform set, and we're gonna call this AES 256 SHA-256 for the alias for this. I got to exit out one here. Knew something was up with that. Okay, crypto IPSec transform set. The alias name is going to be AES 256 SHA-256, and the protocol is going to be ESP AES 256, and the hash is going to be ESP SHA-256. So we've got our phase 2 transform set there that we're calling AES 256 SHA-256. Set up pre-shared key. So crypto ISACamp key, we'll call this test567 address. In real life, you want to make your pre-shared keys much more complex because there are some attacks that leverage weak pre-shared keys. So we're building this configuration for this VPN tunnel. We got a phase 1 policy. We have a phase 2 transform set. And now we want to have a pre-shared key for the tunnel that we're going to configure. And I want to point out here that the 192.168.20.2 is going to be router 3's gig 00 interface. And that's going to be one of the peers for this tunnel. This will be the remote peer from the context of R1. So we've got the pre-shared key in, and then we'll create a crypto map. We'll call the crypto map VPN. We're going to give it a priority number 10, IPSec, ISACamp. Although we haven't created this access list yet, we're going to say match address, GRE VPN, and then here in a minute we'll actually create the access list with that name. I'm going to set the peer to the same IP address that we made the pre-shared key for. And then we're going to reference the phase 2 transform set that we just created. Okay. And then we want to associate that crypto map with the interface gigabit 0/0, which is the kind of simulated internet facing interface. Okay, so we got that crypto map associated with the interface. We can see that ISACamp is on. And we got everything for the tunnel except for the access list. So IP access list extended GRE underscore VPN. Now the really important thing here is that this is a little bit different than what you would normally see. So we're going to permit a GRE protocol, and we're only going to allow that between the two VPN pairs. So 192.168.10.1 and host 192.168.20.2. So to kind of recap, 192.168.10.1 is the IP address associated with the router 1 interface gigabit 0/0, which we're associating the crypto map with. So that's the peer IP for R1. And then the peer IP for R3 is 192.168.20.2, which is the same IP address we've created the pre-shared key for. And referenced in the crypto map entry as well. So the only thing that's going to be allowed over this IPSec VPN tunnel is specifically GRE protocol, and it's got to match the source and destination peer IPs for the tunnel. Okay, so we're good on the configuration for R1. And then we'll just do a kind of mirrored configuration for R3. I should be able to paste most of this in from the notes here. So again, we're going to do a phase 1 policy. So we got that. And we'll do the phase 2 policy or transform set. And I have in my notes here mode tunnel, and I think that's set by default anyways, but I missed that on R1, so I don't think I did that on R1, so let me go back and get that. So paste in that same transform set, and then at that point I can get into the sub command mode tunnel, because yeah, I think I missed that on the one before. Okay, so R1's good. We got the same thing on R3. And put in the pre-shared key. And of course, now we're in the context of R3, so we're actually, whoops. Let me go back to R3 on my notes, and we'll say no to that because that's incorrect. And this time we'll put the correct key in because we're in the context of R3. So the remote peer for R3 is 192.168.10.1, which is the gig 00 interface of R1. So we'll make the crypto map entry, and we'll associate that crypto map with the gig 00 interface, and create the access list that we just referenced in the map. And again, exactly the same as R1, except for now the source and destination have swapped. 192.168.20.2 is the peer IP for R3, and 192.168.10.1 is the peer IP for R1 for this tunnel. And that's it. So basically, what should happen at this point is if I send traffic from the Linux host on the far left, we're going to send some ping traffic to ping the Linux host on the far right, which is 10.0.10.2. So when I send the ping traffic sourced from the Linux host on the far left, it's going to hit the default gateway on R1. It's going to, and so in the routing table, so if I do show IP route, if I send traffic to the 10.0.10.0 network /29, it's going to be associated with tunnel 0 interface, which, as you saw from the previous video, is a GRE tunnel. So I'm going to send traffic, it's going to hit R1, it's going to be looked up for routing, and associated with tunnel 0, which is at that point, then we're getting the GRE encapsulation because of this tunnel interface. And if we look at the, so if I do show run interface tun 0, you can see that the tunnel source is gigabit Ethernet 00. So at this point, we've sent some ping traffic. It's been associated, because of the routing, it's been associated and pushed through this GRE tunnel, and then now we have the encapsulation. And then we know that we've set the source as gigabit 00. Well, we've put a crypto map on that interface, so that GRE encapsulated traffic is now seen as interesting traffic for the site-to-site VPN tunnel, and so that's going to get encapsulated in IPSec and then sent over an IPSec encrypted tunnel to R3. That traffic is going to be decrypted, and when that happens, the router is going to see its GRE encapsulated, so it's going to strip off the GRE, and then it'll have the source and destination IP addresses, and then the destination in this case is going to be the Linux host, and it'll forward it. So basically, we've got two layers of encapsulation. The first one is the GRE, because of that tunnel interface, and then when it goes to forward it out the gigabit 00, it's seen as interesting traffic for the tunnel that we built, and then it's got the two layers of encapsulation between R1 and R3, decryption of the IPSec, de-encapsulation of the GRE, and then forwarding of that original packet to the destination, which is the Linux host on the far right. So if we do a ping to 10.0.10.2, that should cause the VPN tunnel to build. So we do start seeing some ping traffic response. And if we do show crypto IPSec SA, we see that indeed the VPN tunnel that we built or configured has established, and we're in quick mode. And if we do show crypto IPSec SA, then we can see that we've got encaps and decaps for that traffic. So we know that the tunnel's working as expected. And what's really interesting about this is, look at the source and destination IPs of this original packets that we're creating here. The source IP is 172.16.10.2, and the destination IP is 10.0.10.2. Now again, if we do show IP access lists, then you'll see that the only thing that's actually allowed over this VPN tunnel is GRE protocol with these with the peer IPs of the routers. So that just goes to show that there's no way that this the ping traffic sourced from this Linux host would actually be allowed interesting traffic in a security association to build unless we knew for sure that that traffic was first being encapsulated in GRE and then going on from there, as I mentioned previously. So if we do show interface ton 0, when we look at the counters here, we also see the encapsulation. So this, as I mentioned before, this ping traffic that's sourced from the Linux host is first getting encapsulated with GRE, and then because of that, it shows up as interesting traffic for the VPN tunnel, and that's why it's able to communicate with the host on the far right. And so we can do the same thing. So we can ping 172.16.10.2, which is the Linux host on the far left, and of course we have traffic going on, and you have the exact same results over here. So we do show crypto IPSec SA, we got the tunnel up as expected. Show crypto IPSec SA, we got encaps and decaps, and then show interface ton 0, and same thing here, GRE encapsulation. So really cool concept. That's the first time I've done GRE over IPSec. So yeah, hopefully that video was helpful, and thanks for watching.